Skill practice 1, we are given one angle and two sides, and notice that I have side A, side C, and angle B, which must be nested between A, B, and C. So let's draw our triangle. Triangle not drawn to size. So let's say that B is 61 degrees, C is 19, A is 28, and we'll need to know side B. This would be angle A, this would be angle C, and this would be angle B. Remember, when I'm solving a triangle, I like to list the 6 pieces of information that we need once it's solved. Side A is 28, side C is 19, angle B is 61 degrees. We're going to use the law of cosines to find side B first. And remember that B squared is equal to A squared plus C squared minus 2AC cosine big B. Solving for just B, I can square root that, and I would have 28 squared plus 19 squared minus 2 times 28 times 19 times the cosine of 61 degrees. Make sure your calculator is in degrees, and we're going to be rounding to one decimal place. So in this case, B is 25.1. Following the order for solving an oblique triangle given side angle side, we first found the length of the side opposite the angle. Now we're going to use the law of sines to find the measure of the angle opposite the shorter of the two sides. That's going to be angle C that we're going to try and find. So then the sine of angle C over side C of 19 is going to be equal to the sine of 61 degrees over side B, 25.1. We're going to need to use the inverse sine. So the inverse sine of 19 sine 61 degrees over 25.1. Using the inverse sine, we have the inverse sine of 19 times sine 61 degrees over 25.1. That's going to equal angle C. And so angle C is 41.5 degrees. And then lastly, we find the measure of the third angle by subtracting angles B and C from 180. So A plus 61 degrees plus 41.5 degrees is going to equal 180 degrees. And angle A is in 77.5 degrees. Skill practice 2, we are given 3 side lengths. I'm going to draw this triangle, not to scale. The longest side is 62. The shortest side is 41, the middle side is 48. That means opposite side 62 is angle A, opposite side 48 is angle B, and opposite side 41 is angle C, based on the labeling they've given us for A, B, and C. So I'm going to fill in the 6 pieces of information that I want and write down what we have. A is equal to 62, B is 48, C is 41. And the guidelines say that we're going to use the alternate form for the law of cosines to find the largest angle. And the largest angle is opposite the longest side. So that's going to be angle A. Remember, the law of cosines says that A squared equals B squared plus C squared minus 2BC cosine A. We're going to solve for cosine A, which will give us the cosine of A is equal to B squared plus C squared minus A squared all over 2BC. Remember, the signs change because if you subtract B squared and C squared and then divide by a -2, it's just cleaner to write it with the signs changed. So the inverse cosine of B squared, which is 48 squared, plus C squared, which is 41 squared, minus A squared, which is 62 squared, divided by 2 times B, which is 48, times C, which is 41. That's going to give us angle A, which is 87.9 degrees, rounded to the nearest tenth of a degree. I can then find either of the 2 remaining angles using the law of sines or the law of cosines. I'm going to go ahead and use the law of cosines inverse to find angle B. That means that the cosine of angle B is going to be equal to A squared plus C squared minus B squared over 2AC or the inverse cosine of a squared, which is 62 squared, plus c squared, which is 41 squared, minus b squared, which is 48 squared, divided by 2 times a, which is 62, times c, which is 41. That's going to be equal to angle B. Angle B rounded to 1 decimal place is 50.7 degrees. And then lastly, find our third angle measure by taking 180 minus angle B and angle A. And we get that angle C is 41.4 degrees. Skill practice 3 asks us to repeat example 3 with a different initial bearing and speed. So we're given this scenario where a Coast Guard ship is leaving a base at a certain speed on a certain course of bearing, and then 3 hours later a distress call comes in from a cargo ship that is a certain distance away from the base with its own bearing. So what I'm going to do is I'm going to change the bearing to represent what the skill practice is asking us, and then the questions that we are asked is to figure out how far away the Coast Guard and the cargo ship are from each other, and then what bearing the Coast Guard ship needs to follow in order to reach the cargo ship to help it. The initial bearing of the Coast Guard ship is no longer north 82 degrees east. It is now north 17 degrees west. And then instead of going 16 knots or nautical miles per hour, they're doing this at 18. The Coast Guard ship going north 17 degrees west is represented by the blue line on the graph, and the cargo ship going north 48 degrees east is represented by the green line. I'm going to connect the blue line to the green line to show you what distance it is that we are trying to figure out and calculate for part A. Filling in the information that we have, this angle of the blue line to the north-south line is 17 degrees, and the angle from the green line to the north-south line is 48 degrees. We get those from the bearings. We are also told that the cargo ship is 180 nautical miles from the base. So the base is down here, and then we have the cargo ship and the Coast Guard ship. And what we need is how far away the Coast Guard ship is from the base, and we can determine that based on the rate that we were given. So we have 18 nautical miles per hour traveled for 3 hours, gives us 54 nautical miles. 18 nautical miles per hour for 3 hours gives us 54 nautical miles. We are asked the distance between the Coast Guard ship and the cargo ship. I'm going to label the triangle using A, B, and C. Let's call the Coast Guard ship A, the cargo ship B, and the base C. Then the 180 nautical miles is going to be opposite of angle A. We'll call that little a. The 54 miles is going to be opposite the cargo ship angle B. Let's call that little b. And then the base across from that side distance is going to be side distance C because it's across from angle C. We want to find side C, and we're given side angle side, which we can use the law of cosines for. So the law of cosines says that side C squared is going to be equal to side A squared plus side B squared minus 2 times side A times side B times the cosine of angle C. That means that side C is going to be equal to the square root of side A, which is 180 squared, plus side B, which is 54 squared, minus 2 times side A, 180, times side B, 54, times the cosine of angle C, which is the two bearings added together, 17 degrees plus 48 degrees, or 65 degrees. Make sure your calculator is in degrees before you run these numbers, and you will get that C is equal to approximately 164.6 nautical miles. The next thing that we're asked to calculate is the bearing that the Coast Guard ship needs to follow to reach the cargo ship. And so what I'm going to do here is I'm going to add in an image where I've created a coordinate plane at the origin point of the Coast Guard ship so that we can calculate from the north-south line what the bearing is that we need to run. Labeling the information that we have again. The bearing that we are asked to calculate is going to be from the black line to the new north-south line that is the red dotted line. That's going to be this angle right here. I'm going to extend the blue line of the cargo ship to show you that we can use some properties of angles with geometry, of parallel lines cut by a transversal, in order to calculate everything that we need to solve this problem. The red dotted line that is vertical and the black line that is also vertical, so both of these that are supposed to be the y-axis of the different coordinate planes, are parallel to each other. The blue line cuts these two parallel lines as a transversal, and in geometry, we know that when we have two parallel lines cut by a transversal, there are certain angles that are congruent. Corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and opposite vertical angles are congruent. I was told in the beginning that the bearing of the Coast Guard ship to the north-south line was north 17 degrees west. That is the same angle as this new angle created by the coordinate plane in the red dots with the cargo ship. That's also 17 degrees. And the reason why that's important is because this blue line forms 180 degrees. So I'm going to draw a big arc. This big arc is 180 degrees. So that's 17 degrees plus the bearing that we are trying to calculate here, plus this angle right here, all add to 180 degrees. I know 17 degrees. I need to find my bearing, but I can also find this angle, let's call alpha, and we'll call our bearing beta. So our goal is to find beta, but we need to calculate alpha in order to do so. And I can use the law of cosines in the alternate form to find alpha. Okay, I filled in the information that we've calculated. We know that A is 180 nautical miles, B is 54 nautical miles, C is 164.6 nautical miles, and we know that the angle C is 64 degrees. We want to calculate angle alpha, which would be like angle A if I was to use the angle measurement of the ABC triangle. So let's use the law of cosines in its alternate form to find the cosine of A. The alternate form says that the cosine of A is equal to B squared plus C squared minus A squared over 2 times B times C. So the inverse of that is going to be equal to the angle A. The inverse of that is going to be equal to angle A. Plugging in the numbers that we have, B squared is 54 squared, C squared is 164.6 squared, A squared is 180 squared, divided by 2 times B, which is 54, times C, which is 164.6. And that's going to give you angle A, which is approximately 97.7 degrees, which I've also called alpha. Using the fact that angles alpha, beta, and that 17-degree angle are supplementary, they add to 180 degrees. Beta is going to be found by taking 180 degrees minus 17 degrees minus 97.7 degrees. And beta equals 65.3 degrees. So our bearing is then north 65.3 degrees east, because the angle, the bearing is going off to the right. It's going up and to the right, so that's north and east. And that is how you calculate the bearing for part B. The last question asks us to find the area of a triangle with given side lengths. Remember that when you have side lengths, you just need to find the semi-perimeter, which is the perimeter in half, and use Heron's formula. The semi-perimeter is equal to 1/2 15.4 plus 22.6 plus 26. That's 1/2 64 or 32 meters. The area is then equal to the square root of 32 times 32 minus 15.4 times 32 minus 22.6 times 32 minus 26 is equal to the square root of 29,959.68. Rounded to the nearest whole number is 173 meters squared.